So here we are going to move workflow of LangChain with workflow of LangGraph. So with parallelization. So what is parallelization in LangGraph? Okay, so here we can see what is parallelization in LangChain. Okay, so in LangChain, nodes usually execute one after another in sequence defined by edges. Okay, but when tasks do not depend on each other, output they can run in parallel. Okay, this one. Okay, like you have multiple like if you have input like this here, and if you want to run task parallelly and they don't depend each other, so you can execute parallelly like this: task 1, task 2 and task 3. After that, here we can combine it by aggregator, and it will generate the answer. Okay, so here you can see uh, in LangGraph, node usually execute one after another in sequence, but task, if task do not depend on each other, then we can use parallelization in LangGraph, and they can run with the uh, help of parallelization in the form of parallel. Okay, so here you can see how it works. Parallelization achieved by creating multiple nodes that operate independently. These are the multiple nodes, they are working independently here, and connecting them to a common point. Okay, here you can see like start and optionally merging their output into single downstream node. Okay, so connecting them into a common starting point like start this one. Okay, and these are the independent nodes, and now we are going to combine these node here, merging their output into a single downstream node. Okay, so LangGraph handle the automatically when node are independent and can use multiple threading or async execution under the hood like async or thread pools. So here benefit of the speed, they can run independently. Okay, save it's they are they saved your time. Okay, and scalability, handle large workflow efficiently, and modularity, keep the graph structure clean and reusable. Okay, so here uh, what happening here in parallelization. So LangGraph allow to create a workflow of task called a node. Okay, so here some tasks can run at the same time. Some tasks can run at the same time if they don't depend on each other. This is called a parallelization. In this example, we are making a short story, character setting and story premise. Okay, so all three are generated in parallel, then combined into a single story. Okay, so here these things and all three we are going to execute in parallel form, and after that they will combine in a final story. So here you can see workflow of this start. So we can start by using start begin this, it is a beginning of workflow, and generate the character. Okay, so AI generate the character name and trials, generate the setting traits, sorry, generate the setting, AI describe where the story happened, and generate the premise, AI write a one line plot idea, combine the result, AI merge the character setting and premise into a story intro, and end workflow finished. Okay, so here you can see I'm going to load env load your API from .env. So here I'm going to load API, and now and after this I'm going to connect grok LLM. Okay, so here I'm going to write code: import os. Okay, here I'm going to write from, okay, import os, and here you can see from .env .env import load.env, and here after this I'm going to create load under sorry load dot env. Okay, where is my code? Oh, this one. Import OS from .env, import load.env and load.env. Insert a cell above A. Okay. Name load is not defined. So here this is the load underscore .env. Okay. And here you can see from LangChain underscore grok import chat grok, and here I can write this line here, import os dot environment environ. Here I am going to pass API keys variable grok. Here you can see grok underscore API underscore key. Okay, from here I already have the env file, this one. Okay, now I'm going to close this bracket, and here you can see os dot get os dot get env. Here I am going to write again this name, grok API key. Okay, close quotes, and after this I'm going to so okay, here I have load .env file that we can access our API key from env file. Okay, so chat grok connect to grok LLM like OpenAI, but faster, it is faster. Okay, so here I'm going to import chat grok. Okay, and after this I need to write here you can see LLM equals to chat grok. And inside this I need to pass model name. So model equals to in quotes llama hyphen 3.1 8 billion 8b hyphen instant. Okay, so I'm going to use model this one, and here now I need to create a variable which called a result equals to llm dot invoke, that we can invoke query from llm from this. Okay, so here I'm going to write inside this query like hello. Now I'm going to print result. Okay, I need to copy this, and here okay, so move this cell down. Okay, now I'm going to insert cell below. So here I need to copy this. Okay, because it is not in Python, I need to delete this. Okay, so I got error, name chat group is not defined. I already defined this one, chat grok. Okay, so I did mistake here. Okay, it's grok. Okay, so here you can see connect to grok llm. Okay, so here I am going to create llm equals to chat grok model, and this is the model I am going to use in our code that we get answer from this model. Okay, so result equals to llm dot invoke, that we can get answer from this for this query. Okay, and this is the result, and you can see AI message give you how can I assist you today. Okay, AI message equals AI message, here you can see content equals to hello, how can I assist you. Okay, and these are the metadata and everything. Okay, model name, prompt time, queue time, okay, total time, finish time, so everything is here. Now here you can see, you load your grok api, these things, and use llama 3.18 billion parameter model for text generation. Okay, and after this I'm going to create a state. Okay, so state, what is the state? State is like a share memory between the nodes. Each node will read or write to this state, and state dot class state type it. Okay, each node will write here state dot class, each node will write to this state. So here okay, each node will read or write to this state. Okay, so it like a share memory between nodes. So here I'm going to create state class equals to state and type it for typecasting. So here topic should be in string, character should be in string, setting should be in string, and premises should be in string, and story intro should be in string. Okay, so this is the state. Now I am going to build uh, what, so here I need to run it again. Type dict is not defined, I think I missed it. Mm, I need to import type dict also. So here from typing import type dicts, from typing import type dicts. Okay, here after this I already have code inside this file, so I am explaining you again. Okay, this thing. And here I'm going to create a graph. uh, no, I'm going to create nodes. Okay, so I already have code for nodes. So here I need to copy it and paste it here. Okay, actually I did mistake here. I need to import this thing from typing extension. This is the typing extension, not a typing. So here I need to write this and rerun it again. Okay, I need to remove this because I already define it. Now I am going to create nodes. Okay, so here you can see I already create state. Okay, and where each node will read and write to this state. Okay, so here after this from LangGraph import state graph start and end. Okay, from ipython dot display import image and display. So, okay, so these are the nodes. Generating character, I'm going to create node for generating character. Here I'm going to pass state that the node read and write the state. Okay, and generating character, I have explained here in doc stream generating character description. Okay, so message equals to llm dot invoke, and here in f string create two character name and brief traits for a story about the topic. Okay, so return character message.content. Okay, and after this I'm going to create another node getting setting, sorry, generating setting. So here you can see I have already defined start, generating character, generating setting, and these are the nodes, and after this end. Okay, and here generating setting means AI describe where the story happened, and generating character AI create a character name and traits. Okay, and generative generate premise means AI write one line plot idea, and combines means all merges character setting and premise into a story intro. So here we can see generate setting. Okay, so here you can see message equals to llm dot invoke describe a vivid setting for a story about the topic, and here return setting message dot content, and generate premise means generating a premise. Here you can see a message equals to llm invoke write one sentence plot premise for a story about the topic, and return premise equals to message dot content premise colon, sorry, message dot content. And here I'm going to combine these node. Okay, so these node run parallelly, like this one for generating premise, or this one for setting. Here you can see a start, generate character, this is the start, generate character, and here second generate setting, this is the generate setting, this is for generate setting, and this is for generate premise. Okay, so we have three nodes, and now we are going to combine these things. Okay, so here I'm going to pass a state that it will read and write the state. So combine character setting and premise into a intro. So here message equals to llm dot invoke, here write the story introduction using these elements. So this is for character, this is for setting, and this is for premise. Okay, so here we combine these things and return story intro message dot content. Okay, now I'm going to run this.